Okay, so one of the most important words in all of mathematics is this word right here, which of course is a function. You absolutely need to understand what a function is in mathematics because functions are everywhere, especially in algebra, geometry, trigonometry, and this word is widely used, but a lot of people don't know what it means. It's not that difficult, and of course, everyone should know the answer to a basic question like this. And the question is the following: is this thing right here a function? Now, if you have a basic understanding what a function is, this should be a very easy question. But the question itself is we're looking at a set of ordered pairs. Okay, so these are three xy points, if you will. And of course, the question is this a function? Now, the answer is either going to be yes or no. And if you do know the answer, go ahead and put that into the comments section, but justify your conclusions. If it is a function, tell me why or back up that answer. If it's not, same thing. But anyways, I'll show you the correct answer in just 1 second. And even if you're like, I am completely lost, no worries. By the time you finish this video, you'll have a nice review of the basic concepts of a function because this is an extremely big topic in math. So I'm going to kind of distill it down into a nice kind of basic introductory level. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to hit that like button and that subscribe button, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer. Is this thing a function? Well, the answer is no. Okay, it is not a function. Now, the reason why I'm not giving you a justification at this point, like, well, if it's not a function, why not? Because there's a lot of different possible ways you could justify your conclusions. Again, this topic of functions is a huge topic in mathematics. So I'll give you a kind of a full justification of this, as we get into the solution here. But if you understood this question, you're like, no, I know, yeah, know why the answer is no. And if you're like, yes, I have this down, well, gotta celebrate your success about functions by giving you a nice little happy face and A plus, a 100%. And multiple stars so you can brag to your friends and family that indeed you are a professional certified expert in the area of functions. Now, again, this word functions is everywhere in math. When you study different topics, and let's just take algebra for example, we study different things like linear functions, okay, or rational functions, or quadratic or polynomial functions, quadratic functions. This word is everywhere and it has a precise meaning. Now, it's not only just in algebra, it's in things like trigonometry, like trigonometric functions, etc. So again, when you see this word function, it has a very specific meaning and there's implications to it. So let's go ahead and get into this right now. All right, so here's the question: is this thing a function? Well, obviously we don't, we can't even answer this question until we have an understanding what a function is. So what is a function? There's a lot of different ways you can look about this or think about this. And again, this is a big topic, but let me give you some basic examples here because most of you, if you saw something like this, you'd be like, oh, this is a function right here. Yes, indeed, this is a function. And now this is one type of way we can see a function. Okay, so in math, when you have this notation like this f and x right here, this is what we call function notation. Okay, matter of fact, the way you would say this is f of x, f of x. So pretty typical function notation, and the name of this function is f. Okay, so f is the name of this function, but you can have all sorts of functions. You can have g of x, you can have h of t. Let's go ahead and just take a look at this simple example. Again, this is only one possible way to look at functions, so there's just no way I'm going to possibly be able to cover everything here about functions, but this is a very common kind of function notation. Okay, so f is the name, and you can see here we have this x. So this x right here is also, this variable x is also the same variable we use over here. But what is a function in its kind of most simplistic kind of way? Well, we kind of think of it as a rule. Okay, it's a rule where we put in a number. We're going to plug in a number into the function, and then we're going to get something out. Okay, we're going to get a value out of the function. Now, there's all different sorts of things we need to consider here, okay? When it comes to functions, right, you can't necessarily put in every single value into a function. There could very well be restrictions, okay? So the numbers that you're allowed to plug into a function, this is called the domain, okay? The domain is the set of allowable numbers or values you can plug into a function. Now, all the values that you get out of the function, okay, is called the range, all right? Now, I'm not going to get, too detailed here because, we're already using terms like domain and range, and some of you might be like, hey, Mr. YouTube Math Man, I'm not even sure what a function is. Well, again, in its kind of simplest way, just think of it as a rule where we plug in a number and we get a number out. So let's take a quick look at this function right here and this very common algebra notation. And let's go ahead and find a particular value. Let's plug in, let's say 2 into this function. Let's find f of 2. This is what we call evaluating a function. So here I would just replace this x. Here I replace this x with 2. So I'm going to replace this x with 2. So this is going to be 3. Parentheses, we'll put a 2 right here. Okay. And then we got this squared plus 1. So again, order of operations, we got to do this power. So 2 squared is going to be 4. So this is going to be 3 times 4 plus 1. And then, of course, 3 times 4 is going to be 12 plus 1. We'll write this out, 12 plus 1, which, of course, would be 13. Okay, so this particular function we found, or we evaluated is the correct term here. We evaluated this function for 2. So f of 2 is equal to 13. So 2 is a member of the domain, okay, and 13 is a member of the range. Now, you can see functions in all different sorts of ways, okay? So here, I'm looking at functions, at this particular function as an actual kind of equation notation, but you can think of functions also as lines, okay? So when you graph a line like y equals mx plus b, this is what we call a linear function, okay? You can see functions graphically as well. So there's all different sorts of tests and ways to think about functions. Again, this is a huge topic in math, but hopefully I'm doing a basic job here, or a decent job to give you a basic introduction to functions, so at least enough where we can understand how to answer this question. Okay, so if something is not a function, then what is it? Well, let's go ahead and talk about this other word that's extremely important in mathematics, and that is relations, okay? So relations and functions, they go kind of hand in hand like peanut butter and jelly. So all relations, okay, every single relation is a function, okay? So, no, I take that back. I did this backwards, okay? All functions are relations. Some relations are functions, okay? So we can kind of see this way. Kind of just draw a little circle. So we have this whole family of relations, and a subset of relations are functions, okay? So some functions, all functions are relations, and some relations are functions. Now, let's just talk about this graphically, okay? So there is a test. It's an awesome, amazing test for functions. It's actually a graphical test. It's called the vertical line test. And the way the vertical line test works is, let's suppose I have a line like this, all right? And of course, what have like y equals 3x plus 1 could be a linear equation that may represent this line. Now, I'm going to tell you right now that this is a linear function, okay? This is a function, and we could verify that by using this test right here called the vertical line test. Now, the way this vertical line test works is if I draw a vertical line anywhere through this graph, if it only crosses through the graph one time, okay, at any section, then it passes the vertical line test, indicating that this graph, okay, the equation that represents that graph is in fact a function, okay? All right, so that's just kind of a graphical representation of testing for functions. But let's take a look at something that fails the vertical line test, okay? How about something like a circle? So in mathematics, a circle, a formula for a circle, it could be something like this: x squared plus y squared is equal to r squared, or the radius squared, so something like 2 squared. So this could represent a circle. This could be the formula or the equation for a circle with radius 2. Now, if we look at this graph, okay, of the circle, does this pass the vertical line test? Well, let's go ahead and see. If we draw a vertical line anywhere through this graph, it's going to cross through at 2 times. Now, you're like, well, what if I just, put it right here on its tangent right at one point? Well, it doesn't make a difference. If it fails even at one part of the graph, it fails the vertical line test. So this thing right here is not a function, okay, meaning that it is a relation. Okay, so when we assign this word to different things in mathematics, functions, trigonometric functions, polynomial functions, there's implications to that, description. Okay, in other words, oh, this is a function, therefore it has this property, this property, this property, and this property. Okay, so that's why it's really important they understand this word. Okay, of course, we're going to be looking at a very basic problem, and there's different ways we can test for functions. And this particular problem, we're going to be testing using, well, I'm not going to tell you that. I'll hold. I'm kind of build up some suspense here, but hopefully this is kind of bringing back some of this knowledge that you may have learned back in your school days. Okay, so let's go ahead and proceed. And how can we now think about this question? Is this a function? Well, as I indicated, these are xy points, right? Xy ordered pairs. So I'm going to give you a little bit of a hint. Okay, so these are xy ordered pairs. Now, if you have graph paper, you could plot these points. Okay, plot these points. And I already told you one way you could look at this, right? You could plot these points, and then you could consider that vertical line test, all right? So if you draw a vertical line, will a vertical line pass through more than one time? If it will pass through more than one time on this plot here, well, this is not a function. Now, of course, we know the answer is no. But there's another way we can look at this. Matter of fact, let's just take a quick look at this because this is not the main way I want you to answer this question, but it is one way that we could indeed figure this out. Okay, so let me just go ahead and just really in a rough way do this. So let's plot the point 1, 2. So 1, 2 would be something like right here, 1 on the x-axis, 2 on the y-axis. So this would be the point 1, 2. 3, 5 might be over here. So this is 1, 2, 3, and then 5 would be, let's say it's somewhere up here. So there's where 3, 5 is located. Now, where's 1, 7 at? Well, we have to go right here, 1, and then it's 7 way up here, right? So there's 1, 7. But look right here. We're going to get in trouble if I draw a vertical line right here through, at these points, okay, at 1, where x is 1, it's going to cross to this point and this point. So this thing fails the vertical line test. Now, if you answered or you justified your conclusions by saying, no, this is not a function because it fails the VLT, well, that is super impressive and, good on you. But I want you to know another way of looking at this, okay? It's extremely important that you understand this secondary and probably the primary way to understand functions especially when they're given to you in this way, which is, of course, a collection of points. Because like a circle here, okay, you might say, well, why are we thinking about a function as these three separate points? Well, here a circle is a collection of points, but has infinite many points on, the circle. The definition, the technical definition of a circle is just basically all these points that have the same distance from a particular distance, which of course would be the center. Now, of course, we don't want to write out all these infinite many points because that would take too much time, but hopefully you kind of get the idea. Okay, so let's move forward, and what I want to do is talk to you very briefly about something I put together that I think is going to benefit a lot of you. But first, let me go ahead and just ask you to subscribe to my channel If you have not subscribed, please consider subscribing. It really does help me reach as many people that are interested in math and who want to basically improve in mathematics, okay, who need help in math. But a lot of you out there are just kind of, wondering, hey, can I recapture those math skills that I forgot years back? Or, a lot of you also might be thinking, I could have done a lot better in math. Okay, I get a lot of requests where people who want to kind of go back and relearn math. I'm going to tell you right now, you're going to learn, or you can learn, or you will be able to learn. You kind of pick what is appropriate for you. But typically, what I have seen that most people learn math far better later on in life. Now, why is that? Well, probably because you're more motivated. One, two, you're just more disciplined. Three, you're less distracted. If you think about how we learn, math in school, there's a lot of distraction going on. So if you look back, during your time in school and you're like, yeah, you just, I could have done better. Well, then this course is for you. This is a new course that I just constructed. Matter of fact, I'm gonna leave a link to it in the description. I'm calling this my Math Skills Rebuilder course. Now, in this course, you'll be able to relearn basic mathematics, arithmetic. You're also going to learn a ton of algebra and geometry, even basic trigonometry and basic probability and statistics. This is a self-paced course. Matter of fact, it has 18 chapters, so this is something that you just kind of chip away, one skill at a time. But this will be an excellent course for those of you that want to kind of recapture those math skills that you forgot many, many years ago, or for those of you that are thinking to yourself, you know what, I could have done so much better in math only if I had, maybe a better math teacher or I was less distracted. Anyways, I'm going to leave a link to this in the description if you want to check this out. But anyways, let's get back to the problem. Okay, so here is our collection of points. Now we already saw with the vertical line test why this is not a function, but there's another way that we can look at functions, and that is called a mapping diagram, and this is something you need to be very aware of. Okay, so the way a mapping diagram works is the following. Okay, we're going to map x to y. So remember our little function here, f of x is equal to 3x squared plus 1. Remember that example I just did a few minutes ago? Well, what was our input value here? Well, we replaced this x variable. That was our input, okay? So we replaced the x value with a particular number. We replaced this x right here, and then we got our output value. So one value is what we call an independent value. Another value is what we call a dependent value. So when we were talking about functions, the x variable, okay, this variable right here is like our input variable. And our y variable here is like our output. So y depends upon x. Okay, y depends upon x. And again, I'm going pretty quick in terms of explaining it. So if you're a little bit confused, maybe you want to check out one of my courses. Maybe you want to check out my math skills rebuilder course. Of course, I go over functions in that. But anyways, looking at a mapping diagram is an excellent way to think about functions. Okay, so x is our input value, or what we call an independent variable, and y is our output variable, or our dependent variable. Okay. Now, in a function, all these input values, remember, we call this the domain, and all of our output values are called the range. All right, so what we can do here is map all of our x and y. So this is an x and this is a y. So 1 is going to map to 2. 3 is going to map to 5, and 1 is going to map to 7. All right, so let's go and do this right now. So 1 maps to 2, 3 maps to 5, and 1 maps to 7. All right, so what's the whole point here? You might be saying, okay, Mr. YouTube Math Man, how do I know if this is a function or not? Well, here is kind of the primary concept of a function. And again, there's different ways of looking at this, but primary concept is this. Functions, each input value will have one and only one output value. Now, this doesn't make sense right now, and I'll show you another kind of model. But for every x, there's only one and only one unique y. Okay, for every x can only have one y. So look here. So we have 1 that maps to 2. Okay, so this x is going to this 2, no problem. This x here, 3, is pointing to only this y, no problem. But I have this 1 mapping to 7. So you might be saying, oh, this is a function because each x is mapping to 1 y. Wrong, 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 right? See, I wrote this 1 again, but that's not the case. We can only write this 1 once, right? We have 1, so 1 is in fact trying to map to both 2 and 7. This is a no-no. This is right here, cannot be allowed. This is basically a relation, not a function. This is the number one thing you cannot have when it comes to functions. So oftentimes you will definitely see mapping um, uh, situations in terms of various algebra tests and exams on functions. So let's take a look at a few other examples here. So if 1 cannot map to 7, right, this 1 is trying to map with 2 and 7. Matter of fact, let me show you this now, and then we'll come back to this mapping diagram. Another great way to think about functions is as a function machine. So here, let's say we have this machine, and then we throw stuff into the machine and we get stuff out. So our x's are going to be what we're going to throw in, and our y's are going to be what we throw out. So we're saying, all right, let's have some fun with this machine. Let's throw in a 1. Okay, we throw a 1 into this machine, what should pop out? Okay, well, we have to kind of reference our little mapping here. Well, every time we throw a 1 in, we should get a 2 when it pops out. Okay, so we throw a 1 in, we get a 2. Okay, 1 generated a 2. So like, hey, this is fun. I'll tell you, hey, go get another 1, and we'll throw that 1 right back into the machine. What should we get out? Well, we should get another 2. But if we throw a 1 in and then we get a 7, well, there's something wrong with this machine, right? We're throwing in the same material, but we're getting two different out values, right? This is not a function. So let's suppose we had this situation. Let's give you this question right here, which is a very common type of question in algebra. What if I have this, okay? Can a 1, or well, let me just ask you this, is what you're looking at right here, does it represent a function? Does it represent a function? Well, the answer is yes. Okay, each x is mapping to a 1y. That's all that makes a difference. Now, you could have different x's that still go to the same y. Now, visually, this would be what? This would be the point 1, 2, and this would be the point 3, 2. Okay, and these points here are not going to, basically, it's still going to pass the vertical line test. Matter of fact, let's just do this real quick. I know my window here is getting a little bit busy, but let's just do this real fast so you can see. Okay, so here we go. We have 1, 2. All right, so 1, 1, 2. There's 1, 2 right here. And then 3, 2 would be right here. And this would be 1, 1, 2, 3. So 3 2's right here. You can see that there's no danger of passing or failing the vertical line test right here. So visually, you could also verify this. But this is a very typical type of problem. So 1 maps to 2, 3 maps to 2. This is a function. You just cannot have a situation like this. Again, when you have functions in mathematics, this word implies a lot more. There's things like inverse functions. There's all kinds of additional properties, but a huge word in math and algebra. And hopefully, you learned a bit or two about functions. Again, I'm trying to cover things that are taught over the course of multiple chapters. That's why I hope that some of you might consider taking my Math Skills Rebuilder course. You'll definitely learn about functions. And by the time you finish this course, by the way, you'll definitely be able to move on to more interesting advanced math courses like Algebra 2 or maybe even pre-calculus. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.